In lesson number 4, we're going to learn about functions, composite functions, one-to-one functions, and inverse functions. So because it's a pretty long lesson, we're going to be splitting this up into multiple components. And the beginning part of this lesson begins with functions. All right. So first thing that we want to do is be able to tell whether something is a function or not. Let's take a look at this first example. We're looking at the number of calories contained within a given type of sandwich from Wendy's, Burger King, or McDonald's, and the amount of fat that's contained within them, right? So these arrows, all they mean is for a Wendy's single, which contains 470 calories, it's got 21 grams of fat. That's all that says, okay? And so, like this, you're able to use these mapping diagrams. These are called mapping diagrams to tell how much fat something contains. That's all there is, okay? Now, it gets a little bit more interesting when you are talking about multiple arrows or arrows that cross over into other ranges. So, for instance, here you have the gas station, all right? And then here is the price of regular per gallon, so regular gas, basically. And you'll notice that that 7-Eleven and Shell both charge the same amount of money for the price of regular per gallon, right? And so all that's trying to explain to you with the arrows is we don't need to write down $2.72 twice because of the fact that you basically have two of the gas stations that charge the same amount. So we can just make two arrows going to that same exact amount. That's all there is to it. And finally, here, this is the carats. So carat as in like, I would say gold, right? So 0.7 carat, 0.71 carat, 0.75 carat. The closer you get to 1 carat, generally what that means is the more pure the, what do you call it, the gold is going to be. And this is probably the price per entire bricks of it. So it says 1,529 and so on and so forth. Now, one thing you'll notice is for 0.71, this is an issue. It says for 0.71 carats, assuming of gold, I think this is actually diamond, but anyway, but for 0.71, notice how the price is 1575, but then there is another arrow telling you that the price is 1952. So what you should realize from this is a problem, right? That does not make too much sense to us. And so what we conclude is that's not a function, okay? That's not a function that that actually works out for us. And so let's diagnose this a little bit further. So one thing that we can say, so what we'll do is we'll now start giving some names. So this right here is called a domain, all right? And a domain refers to x values. And the other one is called a range. So this is called a range, and it's referring to y values, all right? So there's a domain and there's a range. So every time you notice that there is one arrow going from the domain to the range, you can go ahead and make the conclusion that this is a perfectly valid function. All right? Then for the other one, notice that there was one arrow coming out from every single one of the x's, and it so happens that the arrow from Shell and the arrow from 7-Eleven, they both go to the same exact value. This is still fine in mathematics, and in fact it makes sense even. So this is still a function to us. We're not worried about that. But this last one is a problem. And the reason why it's a problem is you cannot have two arrows, all right? We can't have multiple arrows going from single domain to multiple ranges. All right, that's just one of the ways to look at it. And so what we mean by that is you can't have an arrow going from 0.71 to 1575 and one from 0.71 to 1952. That's not something that's possible. All right. Now, one more labeling technique that we use is we call these inputs. So the domain is often known as the input, and the range is often known as the output. All right, so input and output. So you just learned 3 different words for the same exact thing. So when you hear domain of a function, when you hear x, all right, when you hear input, these all mean the same thing. And when you hear range, and when you hear y, and you hear output, these also mean the same thing. I would say that the most common ones that you'll probably experience are going to be the domain and the range. The domain and the domain being the x's and the range being the y's. All right, let's go to the next piece. Now what we're going to do is we're going to determine whether each relation represents a function, and if it is a function, then we'll state the domain and the range of that function. So let's go ahead and start with letter A. Letter A says 1, 4, 2, 5, 3, 6, and 4, 7. So to see if it represents a function, you just need to make sure of the same thing that I told you in the earlier slide. You got to make sure that every single one of these x's matches up with a y and there is no repeats. So notice how 1 matches up with 4, 2 matches up with 5, 3 matches up with 6, and 4 matches up with 7. There is no problems with that, and so this is a function. All right. This is a function. All right, let's try the next one. The next one says 1, 4, 2, 4. So here's where it gets a little bit more interesting. When it says 1, 4, all right, then 2, 4, a lot of students say, oh, this is a problem. We can't have 1, 4 and 2, 4. That actually is not an issue. That's perfectly fine, right? All that represents, think of it like this. If we had, for letter B, right, for letter B, if we had a column with the x's in it, and we had a column with the y's in it, all right? So this is the mapping diagram. Let's set up the x's. 1, 2, 3, and 6. And then for the y's, you've got 4, 5, and 10. And notice how the 1 goes to the 4. There's no problem with that. The 2 goes to the 4. There's no problem with that. The 3 goes to the 5, and the 6 goes to the 10. So there is no issue with this over here. So this is still considered to be a function. And you want as quick as possible to be able to make that conclusion without having to really draw the diagram that I drew for you in B. Okay, so in the end, what we're going to do is we're going to tell the domain and the range of each one of these, okay, if they are functions. First, we're just going through them and making sure they are functions. Now let's focus on letter C. In letter C, it says -3, 9. Doesn't seem to be a problem with that. All right, so if you like the technique in letter C, you can do the same thing. You can go ahead and set up a column of inputs. So -3, -2, 0, 1, and here's the problem that we're probably going to experience in a little bit. Notice how -3 is mentioned again, all right? So we're not going to write the -3 again, but I'm telling you this is probably going to become your issue. Now let's look at these numbers in the range. You've got 9, 4, 0, 1, 8, right? So let's write the smallest one first. So we'll start off with 0, then we'll go to 1, then we'll go to 4, then we'll go to 8, and then we'll go to 9. All right, now let's draw arrows. First, we're going to go from -3 all the way to the 9. So let's go from negative 3 to the 9, like that. Next, we'll go from negative 2 to 4. So far, no problems here. All right. Then we're going to go from 3 to 5. It looks like I forgot 3 in my, oops, sorry. Negative 3, I got crossed up. So negative 3 to 9, negative 2 to 4, then 0 to 0. I apologize for that. So 0 to 0, no issues with that either. Then 1 to 1, that's perfectly good. And finally, negative 3 to 8, and that becomes our issue. Notice that when you go from negative 3 to 8, you had already chosen a path from negative 3 to 9. And so therefore, letter C is not a function. So that's how we tell if something is a function or if it's not a function. That's it. All right. Now, because letter A and letter B are functions, how do you exactly write their domain and range? So here goes. For letter A, the domain, all right, the domain for letter A is going to be written like this over here. You make a little squiggly bracket and you write down 1, 2, 3, and 4. So you basically take all the x values and you write them in. That's all there is to it. And then for the range, it's going to be 4, 5, 6, and 7. 4, 5, 6, and 7. That's it. Okay, so that's how you tell a domain and a range. Same thing goes for letter B. Letter B, we've already got it written out, so let's just write underneath letter B. For letter B, the domain is going to be the following. It's going to be 1, 2, 3, and 6. All right, and then the range is going to be 4, 5, and 10. All right, so like this, we're able to tell the domain and we're able to tell the range. All right, now for letter C, because it's not a function, and the question says if it is a function, state the domain and the range, letter C is not a function, and so therefore we're not going to be stating any domain and range for it. All right, let's go to the next objective of this lesson and the most important one. Now we're going to learn to find the value of a function, and basically this is the most important slide in this part of the lesson, where you need to be able to plug into functions. Now, some parts of this you may have discovered from earlier and you know how to work with them. So let's go ahead and start with letter A. So first thing you want to do is write down the function. The function is f of x is equal to 2x squared minus 3x. All right, that is our function. And then we're going to go down this list. So let's go ahead and start with letter A. And letter A says that find the f of 3. All right, so we're going to go ahead and find the f of 3. So the f of 3 is equal to 2 times 3 squared minus 3 times 3. So I generally do enough of these where students start to realize what's going on. And so if you haven't caught on yet, basically what happens is whatever goes into this x is going to show up right here, and it's going to show up right over here. So notice how when they said f of 3, you make this into 2 times 3 squared minus 3 times 3, and that's all there is to it. Okay, so I went ahead and I did something like that, and now I can go ahead and evaluate it. So this is going to give me 2 times 9, which is 18, minus 9, and so 18 minus 9 is going to give me 9, and so therefore we make the conclusion that f of 3 is equal to 9. That's it. So remember the idea of input and output? Well, it's the same exact thing that I had detailed for you earlier. When we say x, we're referring to the input. When we say y, we're referring to the output. So in other words, what went into the function was an x, all right? What came out of the function was a 9. So the 9 is my output, and the x is my input. In this situation, the 3 was my input, and that's all there is to it. All right, next we're going to go ahead and try another problem, and we're going to do several of these until you kind of get the hang of it. So letter B, it says f of x plus f of 3. All right, so letter B, let's write it over here, f of x plus the f of 3. All right, now first off, what exactly does this mean? It means that first take an x and plug it into the f function, i.e., you just need 2x squared minus 3x because that's essentially what that was, right? So you already know what this piece right here is. This piece right here is 2x squared minus 3x. We know that. But then when it says add, right? Add f of 3. We also found that from part A. From part A, we already found the f of 3, and the f of 3 was equal to 9, right? It's right over here. So since the f of 3 is equal to 9, we're just going to go ahead and write plus 9 like this. And that's basically as far as that problem really needs to go. Some students have asked in the past is, can we factorize this so we can check 9 because it is a quadratic, so notice, so 9 multiplied by 2 is 18, all right? And 2 factors of 18 that need to add up to -3, yet multiply to +9, that's not going, you're not going to find anything like that, because even if you're thinking of 3 and 6, one of them would need to be negative, and in order for that to happen, then the 18 can't be multiplied to become a positive. And so therefore, this is as far as the answer goes. All right. Letter C. Letter C says 3f of x. All right. So part of the reason why we go through all these is so you're just kind of familiar with, all these notations that you're going to see in this course. So 3f of x. What exactly does that mean? 3f of x means go to the function. Once again, the function is 2x squared minus 3x, and then multiply that to 3. That's all there is to it. So you go ahead and you multiply 3 into this parenthesis, and you're going to end up with 6x squared minus 9x, and that's it. We're done, and that is our answer. Letter D. Letter D says find f of negative x. So f of negative x, now this is where it starts to get a little bit tricky. Notice how the input said f of x is equal to 2x squared minus 3x. And so when we had a 3, I plugged in a 3. Every place there was an x, I substituted with the 3. Now when it says negative x, what this technically means is the following. You're going to go to each one of the spots where there was an x. So I'm just leaving it as a blank right now. And you're going to replace it. Here, let me get rid of this as well. You're going to replace each one of them with a negative x. So negative x, negative x, and negative x, like that. And then you're going to simplify it. So here goes. Recall that whenever there is a negative and it's squared, it always gives you a positive. So negative x when you square it gives you x squared. Therefore, this is going to become 2x squared. And the other one, and a subtraction sign and a negative is going to give you positive. So this becomes plus 3x. Once again, if you would like to factorize this, generally it's a good habit, and you want to get into that habit before we hit more questions that involve factorization and lessons that involve factorization. So there you go. X multiplied by 2x plus 3 is the answer to letter D. Okay, let's try letter E. Letter E says that negative f of x. All right, so negative f of x. What exactly does that mean? Think of it this way. Remember in letter C where it said 3f of x, you multiplied the entire f of x by 3. So now when it says negative f of x, you basically go to f of x. All right, let's write the f of x first. So f of x is 2x squared minus 3x. You're going to multiply it by a negative. That's all that stands for. So if you're going to multiply that by a negative, you have to realize that essentially what that's going to do is it's going to cause everything on the inside to take a positive, an opposite symbol. So this becomes negative 2x squared plus 3x, and we're done with that question as well. Okay? Letter F. It says f of 3x. All right, so these are getting more and more interesting. F of 3x. F of 3x. Notice how this is not, it's not 3f of x. That often gets confused by students. They're like, isn't that saying the same thing? Not really, okay, not really. In one situation, they wanted you to plug x in to the function and then multiply that answer by 3. Here, they actually want you to plug 3x into the function and then do nothing else after that. So it's not exactly the same thing as it was before. So let's try something here. Let's take an old result that we had. All right, so recall when we plugged in a negative x, right? And let's paste that over here. So we have worked with something like this before. All right, we had f of negative x, and we plugged that in, right, and we got something. So this time what we want to do is, instead of plugging in a negative x, we want to plug in a 3x. All right, so let's see what that's going to do. We're going to plug in 3x over here, 3x over here, and 3x over here. So what that's going to do is it's going to simplify to the following. All right, you'll get 2 multiplied by 3x whole squared is 9x squared, minus 3 times 3x is 9x, and then 2 times 9x squared is 18x squared, and that's minus 9x. And finally, you can you can factorize the 9x, so you end up with 2x minus 1. And once again, that is the final answer. All right. Letter G says f of x plus 3. All right, so let's continue moving in the same vein. F of x plus 3. All right, so same exact idea here. What we're doing is we're plugging x plus 3 into the function. Now, one more thing to kind of remind you of, this is not the same thing as f of x plus the f of 3. So I'm trying to help you in red to understand those important parts, and it's just students tend to confuse these things very easily, right? So this is not what was asked to us in part B. Okay, it's not. It's something totally different. In part B, we had to plug in f of x and f of 3 and then add them up, right? Here it's a little bit different. So let's go ahead and try this one out. So once again, f of x plus 3 is equal to 2 multiplied by something squared minus 3 times something. And so purposefully, I am putting everything in here that is being plugged into a different color. Okay, so we're making everything that's being plugged in a different color, so we'll make that red. All right, so x plus 3 goes into the function, and therefore instead of 2x squared, this becomes 2 times x plus 3 squared, and instead of minus 3x, it becomes minus 3 times x plus 3, like that. All right, now let's go ahead and review something. Recall that this piece right here can be simplified using the a plus b whole squared technique. All right, and this is where math starts to get very, very interesting, is where you have to take old pieces of information that you know and put them together. So a plus b whole squared realizes a squared plus 2ab plus b squared. It is not, remember, it is not a squared plus b squared. A lot of students mess that up despite all the warnings. Okay, so This is a squared plus 2ab plus b squared. So now when you apply that formula, you can actually expand this a little bit, and it becomes the following. You have 2 multiplied by a squared, so x squared, plus 2 times x times 3, just writing in all the work for you, plus 3 squared. All right, so all of that is going to be multiplied, remember, to the 2 that's out front. Okay, moving forward, you have a minus 3 times an x, a minus 3 times a positive 3. So this becomes minus 3x minus 9, right? And then simplifying a little bit, multiplying the 2 into everything that is over here is going to give us, let me just get this out of the way, is going to give us 2x squared plus, now 2x times 3 is 6x, and then 6x times 2 is 12x, so 12x plus 9. And then from the rest of that result, it said minus 3x minus 9, right? So putting things together, we end up with 2x squared, 12x and minus 3x make a plus 9x, and plus 9 and minus 9, plus 9 and minus 9, they actually cross one another off, right? So they're not there. And again, notice that you can simplify this a little bit. I apologize, factorize this a little bit. This becomes x multiplied by 2x plus 9. All right, so now we found f of x plus 3 as well. All right, now the last one that we do is letter H, and letter H says f of x plus h minus f of x over h. All right, so let's go ahead and write it up here. F of x plus h minus f of x over h. All right, so if nothing has confused you so far, this generally does the trick. One of the things you want to notice is they mentioned that h can't equal 0. If you're wondering why, it's because if h was equal to 0, then the denominator would be equal to 0, and if the denominator is equal to 0, that's not going to work for you, right? Okay, now, this really happens in parts. One of the first things that we need to do is kind of focus on 3 things that are happening, all right? One of the things that are happening is we need to find f of x plus h, yeah? Then the second thing that's happening is we need to find f of x. That's not too hard. Literally, we've been dealing with f of x the whole time. But there is more. The third thing that happens is you subtract the result from what you got in the first step and the second step. You follow? And finally, the last thing that we do, all right, the last thing, I've run out of space here, but the last thing that we do here is we are going to be dividing that whole result, right? That's the fourth step, by h. All right, so let's go ahead and start with finding f of x plus h. So recall that f of x is equal to 2x squared minus 3x. And just a little while earlier, we had this result, and I really want to kind of look at this result with you. Notice how in this result, when we had f of x plus 3, we plugged x plus 3 into the entire expression. And then that led to other stuff, right? Well, the same exact idea here. Now, when you're going to have x plus h, you're going to do the same exact thing, is you're going to be expanding this a little bit, right? So let's work with step number 1. Let's find f of x plus h. All right, so that's going to make it 2 times, I've been doing this for you in color, so x plus h. Takes time, but I really want you to understand this, so I'll take the time and use the colors. So x plus h, like that, all right? Then we can simplify this a little bit. This is going to become 2 times x squared plus 2xh, or some people say hx, plus h squared, minus 3x minus 3h, like this. And then simplifying that just a little bit further gives you 2x squared plus 4xh plus 2h squared minus 3x minus 3h. Notice how none of that can simplify, but this was step number 1, okay? Now let's do step number 2, which is honestly not going to take too much time because step number 2 was to essentially do what? It was to find f of x. And I'm just being repetitive here, but f of x is given to us in the question. F of x is 2x squared minus 3x. We're done with that. Now step number 3 and step number 4, we're going to put them all together. And step number 3 was to subtract the two results from 1 and 2 and then divide by h. All right, so let's go ahead and detail that for us. So what we got from step 1 is right here. All right, so we're going to take all of that and we're going to subtract everything that is over here. That's basically the idea that we have there. All right, so let me just kind of speed things a little bit forward and take a moment and select these. All right, so that's what we had from step number 1. And then from step number 2, I'm just going to go ahead and write it just to save some time here, is we're subtracting, actually, again, I think it might make more sense to put it in red. So we're subtracting what we got from f of x, and f of x was 2x squared minus 3x, like that. And the whole thing is being divided by h. So let me divide the whole thing by h. Just putting things into perspective for you, recall that this right here is what you got from step number 1. This is f of x plus h. This is what you got from step number 2. This is f of x. And what you're essentially doing is taking the 2, that's what the instructions told us, subtracting them and then dividing by h. Now one thing that you'll notice, just to save some time, is there's a subtraction sign out here. So what's that going to do to everything on the inside? It's going to switch its sign. So I'm going to go ahead and do that. I'm going to write down that the 2x squared becomes a minus 2x squared, and furthermore, the minus 3x becomes a positive 3x, because a negative outside a parenthesis, that's precisely what it does. Now you want to take a look at this carefully. Are there any things that you can actually kind of simplify? So one thing you'll notice is there's a 3x and there is a positive 3x. Well, a negative 3x and a positive 3x will actually cross one another out, so those are both gone. All right. More than that, you'll notice that now there is a 2x squared, so you could have done this in another order too, and there's a negative 2x squared. Same exact idea. Those two will cross one another off as well. All right, so take a look at what you have now. You have 4xh plus 2h squared minus 3h that hasn't been canceled out. And in the denominator, you have an h. Now, as much as you might want to let this go and say, yeah, I'm done with it, look at it carefully again. You'll notice that there is an h in common through the entire numerator. So you can factorize out the h and have 4x plus 2h minus 3, and then in the denominator you have an h. And guess what? What you're allowed to do is you're allowed to cancel the h's with one another. And so the final answer that you get is 4x plus 2h minus 3, like that. If you're wondering where in the world did they get this problem from, this is a problem from calculus. So when I'm teaching calculus, I do these all day, all right? And so now you've kind of learned how to plug things in. All right, now we're going to kind of just detail what is an implicit form and then what is an explicit form of a function. All right, so when something is written in an implicit form, this is just going to take a moment. You'll notice that it's got 3x plus y on one side and it's got 5 on the other side. So if you recall, this is actually the standard form of a line, all right, from a long time ago. Then the second one is x squared minus y is equal to 6. Then the third one is x times y is equal to 4. Notice that what's so special here is the x and the y are kind of like on one side there, right? Whereas when something is explicitly written, what's so different about it is basically that the the y is on one side and the x, all the x's are on the other side. So it's basically solved for you, right? It's solved for y. So if you want one simple technique to remember what is an explicit form, in an explicit form, it's solved for y. All right, that's what makes it so special right there. Um, now, if you take a look at something more that they've written in, it says f of x, right? They all three say f of x. What exactly do we mean by that? This is something you're going to have to start to get used to, is notice that whenever you wanted to find f of x earlier, all that really meant is you plug in, right? That was your input, and what you got out of it was your output. All right, so this entire thing is your output. So to prevent confusion, what you have to understand is instead of calling this another thing, which is called y, what we do is we simply say that y is equal to f of x. All right, so each one of those f of x all together, right, they represent y. So you'll see this a lot. You'll see y is equal to f of x. So don't get confused by it. Here's a second thing that I'll help you kind of realize. Recall that in pretty much every course that we've taken so far, the x-axis is labeled as x, the y-axis is labeled as y. Now, in pre-calculus, you're going to often see that instead of y, they're going to write down f of x. And it actually makes sense because what you're saying is when you plug in an x, when your input is an x, your output is the function of x. Like that is how you read it, okay? Now we're going to focus on finding the domain of a function, and then we'll try to do some of the problems that are also on the homework, but that's pretty much going to do it for this lesson here. So finding the domain of a function can be a little bit tricky, and so what we're going to do is we're going to go through every single one of these. And in letter A, it says x squared plus 5x. So you need to pause. You have to think about this. This is not like your customary math problem where you just plug and chug and you're done with it. So it says x squared plus 5x. So I want you to give it some thought. Is there any number that you can think of, any number at all, that if you were to plug it into this function, it would give you an answer that is undefined? Is there anything that will cause it to become undefined? You can think of negative numbers, you can think of zero, you can think of positive numbers, and the answer is no, there's nothing that would cause it to become undefined. And therefore, the domain of letter A is all real numbers. And what that means is you're allowed to plug anything into this function. Just like when we used to have a classroom and we used to walk into the classroom, your domain was pretty much anywhere in the classroom. You could be anywhere you wanted except at the teacher's desk, all right? So here, this is kind of like saying you can sit anywhere that you want, all real numbers. Sometimes you'll see this written as negative infinity to infinity. That's a common way to look at it in calculus. So don't freak out going like, what in the world does that stand for? That means any number from the negative domain to the positive domain, you can plug that in and you'll be perfectly fine. Okay, so that was a bit easy, right? And so let's take a look at letter B here. Letter B is where things get a little bit more complicated. Letter B says that g of x is equal to 3x over x squared minus 4. All right. Now, can you think of any way that you can make this entire expression undefined? All right. And if you don't know, here is a technique for you. Whenever you have a fraction and you have a variable in the denominator of this fraction, what you want to think about is what can cause this to become 0? And if you don't understand why, it's because if you ever pick up a calculator and you try dividing by 0, let's suppose we had 5 and you divided it by 0, you would end up with an error, right? So you cannot divide by 0. And that's why we need to keep that out of its domain. But that doesn't mean 0 is not in the domain. Be careful, because if you plug a 0 in here, that's going to give you a perfectly good number. So you got to figure out what value of x is going to cause this denominator to become 0. So for that, you have to run a little mini equation. You have to say to yourself, okay, if x squared minus 4 was equal to 0, then what would the value of x be? All right, now technically the way to solve this, there's one of two ways. We'll just pick one. What we'll say is x squared is equal to, bring that over to the right side, equal to 4. And then the square root of x squared is going to give you plus or minus 2. And therefore, we have to keep 2 and negative 2 out of the domain in this question. Again, if you ask why, it's because if you had a 2 that went into this x, it would cause the denominator to become 0. If you had a negative 2 squared would still make a 4, minus 4 would give you 0. So how exactly do you write the domain for letter B? Let's write it over here. The domain for letter B looks like this. All right, first thing that you do is you begin with a little squiggly bracket. Then you put x. Then you put a line. And then you write down all numbers that x cannot equal. So you write down x cannot equal negative 2, and x cannot equal positive 2, like that. All right? So those are two numbers that x is not allowed to be equal to. So that is the domain of letter B. Okay, let's take a look at letter C. Letter C says h of t is equal to the square root of 4 minus 3t. Okay, now you again have to think about, is there anything that would cause this to not be defined? And if you can't think of anything, well, let me help you out. Have you ever tried taking a square root of a negative number? Specifically a square root. Let me find my calculator here. If you try finding the square root of a negative number, like let's suppose that you had to find the square root of negative 5. Notice how that doesn't give you a real answer, because there aren't two numbers that can multiply and give you a negative, right? So what that means is the domain of, and this is where it gets tricky, this always needs to be, all right, needs to be greater than, or equal to 0. And because it has to be greater than or equal to 0, that's how you're going to tell the domain of this, right? So you're going to write down 4 minus 3t always has to be greater than or equal to 0, and therefore negative 3t is greater than or equal to, let's bring the 4 over so it becomes a negative 4, and then you have to divide by negative 3 on both sides. Recall, when you divide or multiply in an inequality by a negative number, it causes the inequality to flip its sign. And so therefore you'll end up with t always has to be a number that is less than or equal to positive 4/3. All right, it's positive because negative divided by negative is positive. So notice how that domain is kind of confusing. All right, so for fractions with variables in the denominator, there's a specific way of telling. You set the denominator equal to 0. For square roots, what you generally need to do is you need to make sure that it's a number that's greater than or equal to 0. All right, so how do you write down the domain for letter C? Let's go ahead and detail it right here. For letter C, again, make a squiggly bracket, T, and then you write down that T always has to be a number that is less than or equal to 4/3. There you go. All right. Finally, let's try letter D. All right, let's see what letter D is all about. All right, letter D is looking a little bit more complicated because it seems to have more than just one thing there. So in letter D, you've got f of x is equal to 3x plus 12, and then that's further divided by x minus 5. So if you really think about it, it's taking both of the concepts in letter B and C, and the book does a beautiful job of this every time. And it's talking about a question that contains both, right? So let's talk about the easy stuff first. Let's look at the denominator. What did we say in letter B can't happen in the denominator, right? You can't have x minus 5 end up being equal to 0. So what's that number that's going to cause it to equal to 0, right? What's the thing that's going to cause the problem? So if you do a little mini equation, you'll say x minus 5 is equal to 0. Therefore, x would be 5. And many students can just kind of look at it and say, yeah, x can't be 5, right? And so what that means is you have to exclude 5 from the domain. So let's just kind of update the domain. All right, here's the domain. X is not allowed to be equal to 5. But there's more, right? You can tell clearly there's more, and here's why. Is because notice how the top has a square root in it. And so because the top is the square root, what is the what is the thing that we said about square root? It needs to be the number inside, or the value inside needs to be greater than or equal to 0. So now we need to set up another equation, more like an inequality. You have to say 3x plus 12 always has to be a number that's positive, or 0, right? So now solving this inequality gives you 3x is greater than negative 12, and therefore dividing by 3 on both sides, x is greater than or equal to negative 4, like that. Okay? So first, you had said that x cannot equal 5, but then this one is saying x has to be greater than or equal to negative 4. So what you do is you update the domain. You simply update the domain, right? So here we had one domain. Here we have a bit of an overlap, really. It says x has to be greater than or equal to negative 4. So you take these two. This is what's confused students in the past. You take both of these domains and you write a single domain out of them, because that's really what the answer lies in. So what are we going to do? We're going to write the following. We're going to write down x has to be a number that's greater than or equal to negative 4, comma, x cannot equal 5, though, like that. Okay, so this is a little bit more confusing, but that says that everything that x can be and everything that x cannot be. And the reason why x cannot be certain numbers is because it would cause the entire expression to become undefined. All right? Finally, in number 84, what we're going to do here is we're going to take a look at really what's more of a homework problem, really. It says f of x is equal to 3x squared minus bx plus 4, and f of negative 1 is equal to 12. So what is the value of b? So let's try this out. Number 84. If you know that f of negative 1 is equal to 12, so here's what you can say. You can say that f of negative 1 is equal to 3 times negative 1 squared minus b times negative 1 plus 4, right? All I did is I simply plugged in the value of x, right? And they're telling you that the answer is supposed to equal 12, so I equal it to 12, meaning they already know what the output's going to be. And that, if you look at it carefully, is going to help you solve for b. So this is going to become 3 times negative 1 squared, which is simply 3, plus b, because negative b and negative 1 make a b, plus 4 is equal to 12. All right, and so this is going to become b plus 7 is equal to 12, and therefore we have a value of b. The value of b is going to equal 5. So that's how you do question number 84. Number 86 is quite similar, so I will leave that to you, but basically the whole idea in number 86 is you have to be able to plug 2 into this problem and equal that to half. And one thing that I will give you some direction with is you're going to end up using cross multiplication when you need to solve for x. All right, that's how you solve proportions. Sorry, when you need to solve for b. And that's what I'll leave it to. Okay, and the last one that I want to discuss before we end this lesson is number 94. Number 94, it says that you have a function, and this is really what functions are used for, by the way. This is their actual real life application. It says n of r. is equal to an equation. All right, I won't write down the equation. That's not that important right now. Now, it says that the n, all right, is the number of housing units in millions. So then basically the number of houses in millions, right? And R represents the rooms, all right? So where it says R is an integer between 2 to 9 rooms. Now, if you don't know what an integer is a negative or a positive whole number, and it would make sense that you have only integers, right? So nobody has 2.1 rooms. They either have one room or they don't have one room, right? So um, that's why R is an integer. Now, basically what this means is if you plug a number into this equation, right? If you plug in the value of 2, let's suppose, into this equation, it's going to tell you how many millions of housing units in America contain that many rooms. That's all that stands for. So letter A says identify the dependent and the independent variables. So let's go ahead and write this down. The dependent variable, all right, the dependent variable is always the y variable. All right, you probably learned that in science. So the y variable is the dependent variable. In this context, the dependent variable becomes n. All right, so that would be our n of r. All right, so dependent variable is your n right there. Okay, and more specifically, we refer to it as n of r. That's it. What is the independent variable? The independent variable is the x variable. In this situation, the x variable is going to be r. All right, and so again, the independent is r. How is this similar to what we learned then? Because this whole lesson we've been talking about f of x is equal to negative 1.44 x squared plus 14.52x minus 14.96. And all they've done is they've put some teeth into this argument, and instead of calling it f of x, they call it n of r. Okay? So really quickly, as this lesson is starting to approach almost an hour now, really quickly, let's do letter B here. Letter B says evaluate n of 3, and then provide a verbal explanation of the meaning of n of 3. So the n of 3 is equal to negative 1.44 3 squared plus 14.52 times 3 minus 14.96. All right. Now you may pick up a calculator and you may type this into a calculator. It would probably be a lot easier. So in a calculator, let's go ahead and write this in. Let me just move this a little bit so that the calculator is visible. All right, so here goes. Negative 1.44 times 3 squared plus 14.52 times 3 minus 14.96. All right, and you end up with 15.64. So when you end up with 15.64, remember this is in millions, right? That's in millions. And if you're wondering what does that exactly mean, that means this is actually, here goes. All right, so when we say 15.64 million, that actually means multiply that number by, 1 million. Okay, so six times you have to move that decimal place. So really we're talking about 15,640,000 houses in the United States have 3 rooms in them. Okay, that's what that stands for. So when it says provide a verbal explanation of the meaning of n of 3, that's important. That's what that stands for, is there are 15,640,000 houses in the United States that contain 3 rooms in them. All right, that's what that gets to you. All right, we're going to go ahead and stop here. Thank you for listening to the lesson, and good luck in completing the homework.